Hello judges, students, and anyone else who is watching this presentation. My name is Nika Pacifici, and my project is called Head on a Swivel 2.0, Brace for Impact. Head and neck injuries in sports can lead to devastating consequences, such as concussions, whiplash, and even death. All athletes are at risk for concussions. However, women and children are at a greater risk due to their weaker neck muscles. But if one has the internal and external tools to help them brace for impact, then this should reduce linear and rotational acceleration and whiplash-like impacts. The objective of this project is to develop a prototype device to increase the neuromuscular stabilization of the neck and cervical kinesthesia. My experiment from last year, Head on a Swivel 1.0, showed that helmets have no significant effect at reducing rotational force and therefore preventing concussions. This is because they did not support the neck or torso, which allows the head to move independently and quickly snap forwards and sideways. Research shows that injury risk curves resulting from hits involving linear and rotational acceleration are sigmoid. If you can reduce acceleration during the steep part of the sigmoid curve, then the concussion risk decreases by 75%. However, if you cannot reduce acceleration during this period, then concussion risk only decreases by 25%. Devices that follow this criterion have the potential to reduce the risk of concussions. The problem is that helmets and other protective equipment that are used in contact sports are not able to protect athletes against concussions. Concussions are more likely to happen because of linear and rotational acceleration, and this means that athletes with weaker neck muscles are more vulnerable and do not have the tools to protect them from these dangerous plays. However, there is a solution. A prototype device can be created to stiffen up and mimic neck muscles and increase cervical kinesthesia and neuromuscular control to help reduce angular acceleration after concussive force impacts. The purpose of this project was to design and test a prototype that could reduce the linear and rotational acceleration of the head in the types of collisions that most often lead to concussions. The hypothesis was that the risk and severity of concussions can be prevented by a prototype that can strengthen and stabilize neck muscles, improve neuromuscular control of the neck, increase the duration of the impact impulse, and reduce linear and rotational acceleration of the head. These are the materials that I used with my project, including a Reebok hockey helmet, and the Spio, and two Rawlings baseball straps. During the innovation and experiment process, I followed these methods. The full method is in my report. This is just a summary. First, I constructed and designed my prototype by first performing a literature review describing the types of impacts related to concussions. I identified the link between weaker neck muscles and higher rotational and linear acceleration. My prototype consisted of two Spio straps attached to a balaclava and a Bauer compression shirt. The design also incorporated a helmet equipped with extra padding and a spider-like design, and two chin straps resembling the Hans device that were secured by bolts on the helmet and bolts sewn onto the dummy. I then created a pendulum swing and a crash test dummy. After this, I performed the physics and calculations of the experiment. This was done by finding the height of the pendulum swing, the velocity the weight was traveling at, and the final velocity of the weight when it struck the mannequin's head. Then we were able to conduct our experiment with accurate results. During the experiment, I performed the test 5 times for each group, a control group and these 4 experiment groups. To perform these tests, I swung a pendulum from a starting point 0.5 meters above the table and moved the swing 45 degrees from the starting point. The pendulum traveled 1.4 meters per second and struck the mannequin's cheek. To observe the experiment, an iPhone camera was used to record the impacts and see how much the head rotated and to see the amount of time the head took to stop rotating. Here are the data and results of my experiment. The averages for the control group and the mean distance was 55 degrees, and the mean time was 0.78 seconds. For the first trial using SPIO without a helmet, the mean distance was 23 degrees, and the mean time was 1.41 seconds. The second trial of SPIO with a helmet had a mean distance of 18 degrees and a mean time of 1.28 seconds. The last trial using SPIO with a helmet and the Hans-like straps had a mean distance of 17.8 degrees and a mean time of 1.42 seconds. You can really see the change in rotation from the head and with the prototype and without. The analysis of results. The control group's averages resulted in very high values of linear and rotational velocity and acceleration. The groups involving SPIO decreased absolute values of rotation and, more importantly, significantly increased the duration of the impact. The complete prototype was the most effective, having the smallest average rotation and the slowest time, indicating that the linear and rotational acceleration, speed, or final velocity decreased when this happened. In conclusion, my hypothesis was correct. All the materials independently and together significantly reduced how much the head rotated. The prototype increased the time of collision and therefore significantly reduced linear and rotational acceleration because of a glancing blow to the head. My prototype shows that stabilizing the neck and head, synchronizing movement between the neck and torso, and increasing the time of impact are beneficial in reducing the rotational and linear acceleration of the head, which could potentially reduce concussions. The prototype is unique because, unlike the Q-collar, it aims to increase cervical kinesthesia and neuromuscular control by using SPIO and having a Hans device-like system. My project was not perfect, and it had several limitations that are listed here, such as basic calculations and possible human error. However, in the future, experiments could use more realistic crash test dummies and advanced measuring tools. There is the potential to bring a similar device to the market. If this prototype was improved and validated, then there is no reason why it could not be used by players. If I had the chance, I would definitely use it. This prototype can no doubt change the viewpoint of concussions and improve player safety. I would like to thank the following people, and I would like to thank you for listening to my project.